All right, this is section 8.3, and today we're going to talk about how to show a quadrilateral is a parallelogram. So kind of like a proof, but not what you remember about two-column proofs. Here we're actually going to use formulas to prove it, and we're just focused on proving that's a parallelogram. So there are 5 different ways to prove that, and then we're going to talk about what formula you need, how many times you need to do the formula, and what you're going to use the formula on. So we're going to kind of break it down. So the first way you can do it is you can show that opposite sides, sorry about that, are parallel. So you would need the slope formula, which is y2 minus y1 and x2 minus x1. And you would have to do that 4 times. You would use the formula on all the sides. And you need opposite ones to be equal. That's how you would prove it. Next up, you could prove that opposite sides are congruent. So you'd have to show that they have the same length. So you would be doing the distance formula. And you would have to do that 4 times, one on each side of the parallelogram. So all sides, and you would need opposite ones are congruent. So 4 distance formulas. Next up, you could show that opposite angles are congruent. Sorry, let's skip that one. Let's do opposite. Oh, dang it. Let's do diagonals. I was trying to put them in an order that kind of went the ones that you want to do first. Okay, I lied. We're going to do one pair opposite sides, parallel and congruent. Okay, so these two are doing all 4 sides, all 4 sides. This one is saying if you just want to do one pair of sides, like here's your parallelogram, you have to prove that they're congruent and that they're parallel. And if you can do both of those things, then it is a parallelogram. So you would need to do slope and distance formula. You would still need to do it 4 times. You would do 2 distance formulas and you would do 2 slopes, 1 pair of opposite sides. So pick a pair of sides, do slopes, do distance formula, and you're done. But it does require you do formulas 4 times, 4 different formulas. So if you like slope formula and you're really good at that, just stick with that one. If you like distance formula and you're good at that one, stick with that one. This one's got a mix, so you're going to do 2 of each. You're going to do 2 slopes and 2 distances. Another one that you can do is you can show that diagonals, that's the one. Diagonals, I can spell, bisect each other. So when they bisect, that means that they have the same middle. So their middle point is the same for both of them. So that means that you would be doing the midpoint formula. And that looks like this, x2. What's interesting about this one is since you're talking about diagonals inside the parallelogram, you only have 2 of those, which means you only have to do the midpoint formula twice, once on each diagonal. What's tough for kids when they pick this one is you need to make sure you're doing diagonals. Don't accidentally do a side, otherwise you'll have the wrong answer. So you have to make sure that you're doing from a corner to a corner, not a side to a side. So you're going to use the formula on both diagonals. And I am going to just underline diagonals and make sure that that's what you're really using. The last one is really hard. We don't ever do this one. This is showing that both pairs opposite angles are congruent. There's not a formula for this. Congruent. Usually it involves you like more of a 2-column proof because you have to prove that the angles are congruent. And so you usually end up having to do like some supplementary stuff first and then getting to congruent. This one's not really used a whole lot, so you're going to pick one of the other 4. So we're just going to kind of do this. So when I say which one of the 5 are you using, this is what I'm talking about, and it's technically which one of the 4. We're not going to use that one. So this one is saying, you know, show KLM as a parallelogram. You're going to pick one of these. Do you want to do slope formulas, distance formulas? Do you want to do a mix, or do you want to do midpoint? Midpoint involves the least formulas, you don't have to do it twice, but you do have to make sure you're doing the diagonals or you're going to have the answer incorrect. They have to have the same, I should put in here, same midpoint. Excuse me. So when you are going to show that this is a parallelogram, excuse me, you need to show one of the 5 ways. I'm not sure what I meant to write there. I guess I should say, which one of the 5 ways are you going to choose? I'm going to do all of them so you can see all of it, but you just have to pick one of those ways. So whichever formula you like the best. So whichever one you're going to do, why don't you pick right here, distance, slope, or midpoint, and then pause the video and try it, and then check to see if you're right. So I'm going to do it all of the 3 main ways. And the work that I show, I need for yours to look like that as well. Some students really forget to label things and show me what they're doing, and then it's really hard for me to follow or to correct. So I'm going to do 4 distance formulas. And I need to make sure I'm doing those on the sides. So I'm going to list out my sides. The first one is from L to M. Then I've got from M to N. Then I've got from N to K. It's hard to tell that that is just an N, by the way. Then we've got from N to K, and then we've got from K to L. Those are my 4 sides for distance formula. I will do the same thing for slopes. So it'll be all the same sides. But notice how I am labeling them all. So when I'm following your work on the test, or even in your homework, I have to be able to tell which sides you're doing what on. So label it. I'm about to do distance. I'm going to do it on these 4. I'm going to do slopes. I'm going to do it on these 4. And then we'll talk about midpoints here in a moment. So first from L to M. So distance formula is the big square root one. So from L to M, I'm just going to do 6 minus 4 and then 0 minus 4. So 6 minus 4 is going to be 2 squared. And negative 4 squared. So if I type that in my calculator, I would get square root of 20, which is totally fine. I don't need the decimal. You can write the decimal if you want to. Remember, you're just trying to make sure that it's going to be the same as its opposite side. So LM and NK are opposites, and then MN and KL are opposites. So I just want to make sure that those 2 end up both being square root of 20. So now we're going to do MN. And MN is going from right here. So I'm going to do 6 minus 4. And then I'm going to do 0 minus negative 2. So I get 2 squared again. And here I have 2 squared again. So I end up with, this being 4 and 4, I end up with square root of 8. Again, if you want to write the decimal, it's fine. You can just leave square root of 8. We're up to NK. So from N to K, I'm going to do 4 minus 2. I'm going to do negative 2 minus 2. So first I have 4 minus 2, which is 2 squared. And I have negative 2 minus 2, which is negative 4 squared. And I can already tell those 2 are the same. I got a 2 and a negative 4, so I'm going to get square root of 20. So yay, did it. They're a match. Let's check that the last one is. So from K to L, I'm going to do 4 minus 2. I'm going to do 4 minus 2. So 4 minus 2 is 2, and 4 minus 2 is 2, and I know that that's a match, so square root of 8, so I did it. That's how you do it using distances. So LM, now I'm going to do my slopes. So LM, we're going to do y minus y, so 4 minus 0. I should have left myself a little bit more room, and then 4 minus 6. So 4 minus 0 is 4. 4 minus 6 is negative 2. Remember, you want to reduce this. So this will be negative 2 over 1. MN is going to be 0 minus negative 2. And it's going to be 6 minus 4. So I'm going to have 2 on top, and then I'm going to have 2 on the bottom. Reduce that, so you get a 1. From N to K, so I'm going to have 2 minus negative 2. And then I'm going to have 2 minus 4. So up top I have 2 minus negative 2, that's 4. On the bottom I have negative 2, so I get negative 2 over 1. Oops, negative. KL is my last one, so I'm going to do 4 minus 2. And then I have 4 minus 2 again, so I get a 2 over 2, which is a 1, and I have matches. My opposite sides are parallel. Last, I'm going to show you the midpoint. So if midpoint is the one that you chose, so midpoint, you have to make sure you're doing the diagonals. Your first diagonal would be L to N. Your second diagonal would be from K to M. So make sure that those are the two diagonals you're doing. Don't do MN, don't do NK. Those are all the outsides. So those are distance and slopes. If you're going through the middle, then you need midpoint formula. So from L to N, we're going to add up the x's, 4 plus 4, and 4 plus negative 2. So 4 plus 4 is 8 divided by 2, which is 4. And 4 plus negative 2 is 2 over 2, which is 1. I got to get this one to match. So K to M right here. 2 plus 6 and 2 plus 0. 2 plus 6 is 8 divided by 2, and 2 plus 0 is 2 divided by 2. So it looks like I got another match. So if when you're doing any of these formulas, they don't come out equal, go back and check your math because they have to. They will match. The last thing we're going to talk about is how to write a summary statement. So you are going to summarize what your work showed you. So if you did the 4 distance formulas, you could say KLMN is a parallelogram because opposite sides are congruent. Just as easy as that. You're pretty much stating what we were trying to prove. It's a parallelogram. And then you say, because I did the distance formulas and the opposite ones are congruent. Great. You could, if you did all the slopes, you could say it's a parallelogram because opposite sides are parallel. If you did the diagonals, then you would say because diagonals, you could say have same midpoint. Let's squeeze this in here. Oops, midpoint. You could also say they bisect each other. Diagonals bisect, put that in there, each other. Okay, so your proof is not really like a proof like you remember. We are definitely doing formulas. You need to make sure that your opposite ones are equal. They will be. Or when you're doing midpoint, that your diagonals, make sure you're doing the diagonals, they also will match. So if any of those are not coming out to be equal, it's kind of like a tip off that something's wrong. Summary statement, this is totally worth points on the test. You summarize what we were trying to prove. KLMN is a parallelogram because, and then just tell me what you did. Opposite sides were congruent, opposite sides were parallel. You could say opposite sides had same slope. You could say opposite sides had the same distance. You could say midpoints had the, diagonals had the same midpoint. Like just say what formula you used and what happened.